So in 8.2, we're going to be taking the derivative of log functions. So starting with ln, the derivative of ln of x is 1 over x. It's not just going to be x that we're taking the ln of. So the derivative of ln of u is 1 over u times the derivative of u. So it'd be the derivative of u over u. So whatever we're taking the ln, that's going to go into our denominator. And then the derivative is going to go up top. So let's do some examples. For a, we have the ln of 2x. So what we're taking the ln of is going to go on the bottom, 2x. We take the derivative of 2x, and that goes up top. What's the derivative of 2x? 2. So this would simplify to 1 over x. So this would be our derivative. Let's do b. So what we take the ln of is going to go on the bottom. So x squared plus 1. Then our derivative of this is going to go up top. What's the derivative of x squared plus 1? 2x. Awesome. So that's our answer. For C, we have to do the chain rule. We have two terms here. We've got x and ln of x. So not the chain rule, we're doing the product rule. So our product rule is the first times the derivative of the second plus the second times the derivative of the first. So the first would be x times the derivative of the second. What's the derivative of ln of x? 1 over x, perfect. Plus the second, ln of x, times the derivative of the first. What's the derivative of x? 1. So we can simplify this. We have x times 1 over x. What would that simplify to? 1. Awesome. So our derivative would be 1 plus the ln of x. Let's do D. Here we have to do the chain rule. So because it's cubed, the whole thing, ln of x is cubed, we can't just move the 3 in front. This is different than if we had the ln of x cubed. If I had the ln of x cubed, I'd want to move the 3 in front, make it a coefficient. But these are two different things, not the same. So here we want to use our chain rule. We're going to take the derivative of the outside, so move the 3 to the front, times the ln of x to the second power, times the derivative of the inside. What's the derivative of ln of x? 1 over x. So we have 3 times the ln of x squared over x. This would be our derivative. Let's look at example 2. So when we have something like this where we're taking the ln of something with an exponent, bless you, the easiest thing for us to do is going to be move that exponent and turn it into a coefficient. We could take the ln of x plus 1 to the 1/2 power, but then when we do that, we end up having to use the chain rule. It's just going to make it more complicated. So let's do the ln of x plus 1 to the 1/2 power, but we're going to move the exponent to be a coefficient. So this would be 1/2 times the ln of x plus 1. So now when we take the derivative, that 1/2 is just going to hang out front. Let's take the derivative. Because it's a coefficient, we can just leave it out front. Let's take the derivative of the ln of x plus 1. So x plus 1 is going to go in our denominator. And then the derivative of x plus 1 is going to go up top. What's the derivative of x plus 1? 1. So let's write this a little bit better. Our derivative is going to be 1 over 2 times x plus 1. You could distribute it. You don't have to. I think WebAssign would probably take this as an answer without distributing it. Example 3 is kind of similar. We have x times the square root of 1 minus x squared. So we could just take our derivative of this right off the bat, but then we'd be doing the product rule and it'd just make it a little bit more complicated. So to simplify, we can use our properties of expansion. Since we're multiplying these, if I were to expand it, what goes with multiplication? Addition. So we could expand this to the ln of x plus the ln of 1 minus x squared to the 1/2 power. But what do I want to do with that 1/2 power? Bring it to the front. So we have 1/2 times the ln of 1 minus x squared. Now we can take the derivative of each one of these separately. What's the derivative of the ln of x? 1 over x, perfect. Plus, we have 1/2 times, what's the derivative of ln of 1 minus x squared? What's going to go on the bottom? 1 minus x squared. And then the derivative of 1 minus x squared is going to go up top. What's the derivative of 1 minus x squared? Negative 2x. From here, let's simplify. I see that I have a 2 on the top and a 2 on the bottom, so those are going to cancel. So I have 1 over x plus negative x, or I'll make it minus x over 1 minus x squared. Let's simplify this a little bit more and make it one fraction. So if I were to subtract my two fractions together, what do we need? A common denominator. So I can multiply my fraction here by x over x, and then I'm going to multiply my first fraction by 1 minus x squared and 1 minus x squared. So I get 1 minus x squared up top. On the bottom, we have x times 1 minus x squared. And then minus here, what's x times x? X squared. So we could simplify this a little bit more. 1 minus, what is negative x squared minus x squared? Negative 2x squared, perfect. So this would be our derivative. Our simplified derivative. So WebAssign's probably going to make you combine it just to be one fraction. So find a common denominator and add them together. All right, so we're finding the derivative here. We're going to use the same strategy we did in the last one. So let's expand it. We have the ln of x. I'm multiplying x times x squared plus 1 squared up top. So I'm going to add the ln of x squared plus 1 squared. Then, since 2x cubed minus 1 is on the bottom, what are we going to do with that one? Subtract it. So minus the ln of 2x cubed minus 1 to the 1/2 power. What do I want to do with my exponents? Bring them to the front. So we're going to put them in front of the ln that they are attached to. So the ln of x plus 2 times the ln of x squared plus 1 minus 1/2 times the ln of 2x cubed minus 1. So let's take our derivative. What's the derivative of ln of x? 1 over x, perfect. Then we have plus, we're going to multiply 2 times our derivative of the ln of x squared plus 1. So x squared plus 1 is going to go on the bottom. What's going to go up top? 2x, perfect, the derivative. Then minus 1/2 times 2x cubed minus 1 is going to go on the bottom. What's going to go up top? Awesome, 6x squared. Let's simplify. So we have 1 over x plus, here this becomes 4x over x squared plus 1. and then I can simplify here. 2 goes into 6 3 times. So minus 3x squared over 2x cubed minus 1. We'll leave it separate for now. But if Webassign didn't take this as an answer, find a common denominator. So you'd have to multiply by the missing denominators of the other two and just combine them together. Example 5, we want to find the relative extrema. So to find our relative extrema, we need to do the derivative and set it equal to 0. So let's find our derivative and set it equal to 0. So our derivative here would be x squared plus 2x plus 3 on the bottom. What would be up top? 2x plus 2. Perfect. Now we would set our derivative equal to 0. So which part of this would I need to set equal to 0? The numerator. But we also need to figure out where it's undefined. So we want to set the denominator equal to 0 as well. So to find our critical numbers, we want to find where it's equal to 0 and where it's undefined. So let's set our numerator equal to 0. 2x plus 2 equals 0. X equals what? -1. When we set our denominator equal to 0, do we have two factors of 3 that add up to 2? No. So we don't get any critical numbers from the denominator. So our only critical number would be x equals -1. So this would be our critical number. Let's figure out if it's a relative max or min. So I'm going to draw my little chart. So from -infinity to -1, and from -1 to infinity. So we could plug in something like -2. So we're plugging that into our derivative to see if it's positive or negative. When I plug in -2, I'll write it all out. Up top, we would have -4 plus 2, which would be negative. On the bottom, this would be 4 minus 4 plus 3 would be positive. So what's a negative divided by a positive? Negative. So this is less than 0. It is negative. Are we increasing or decreasing? Decreasing. Let's do the same thing for our second interval here. What's a good number to plug in the second interval? 0. Awesome. So we plug in 0. We have 2 times 0 plus 2. That gives us a positive up top. And then 0 squared plus 2 times 0 plus 3 would give us a positive on the bottom. So positive divided by positive is positive. So we're greater than 0. We're positive. Are we increasing or decreasing? Increasing. So we are decreasing and then increasing. What would -1 be? A relative minimum. Perfect. So we have a relative minimum at -1 comma, how would I find the y value? Plug it into the original. Awesome. So the ln of -1 squared plus 2 times -1 plus 3. So this would be 1 minus 2 plus 3 would be 2. So the ln of 2 would be our y value. So to find our y, we found f of -1. We plugged it into the original. It says, on occasion, it's convenient to use logarithms as an aid in differentiating non-log functions. here are the steps. So this is logarithmic differentiation. So sometimes when we don't even have a log function, using logs is helpful, or using our ln's is helpful. So first step we want to do is take the ln of both sides. Then we use the log properties to rid ln of u as many products, quotients, and exponents as possible. So we would then want to expand. So step 2 is just saying to expand the log, because it's easier to take the derivative of things that you're adding than things that are being multiplied, because if we're taking the derivative of things being multiplied, we'd have to do the product rule. But if it's just adding, we just take our derivative like normal. Then it says differentiate implicitly. So we want to take the derivative of each side. So when we take the derivative of the ln of y on the left side, the derivative of the ln of y is going to be the derivative of y over y. So just like we were doing yesterday. But it's just y's here. Then we'd take the derivative of the right side also. Then we want to solve for the derivative of y, because that's essentially what we're finding. So let's look at example 6. So we could take the derivative here. We'd have to use our product rule, and since we have a square root, we'd have to use our chain rule too. But we're going to use our new log strategies that we know. So I'm going to take the ln of both sides. So we have the ln of y equals, here I have the ln of x times the square root of x squared plus 1. We want to get rid of as many products, exponents, and quotients that we have here. So if I'm multiplying these two things together, what could I do to get rid of the multiplication? How could I expand it? Make it addition. So I can say the ln of x plus, and then this is the 1/2 power. So I'm going to do 2 steps in one. So plus 1/2 times the ln of x squared plus 1. From here, we're going to take our derivative. So the derivative of the ln of y, because we have to differentiate both sides, is the derivative of y over y. And then what's our derivative of the ln of x? 1 over x, perfect. Plus 1/2 times the derivative of ln of x squared plus 1. So x squared plus 1 is going to go on the bottom. What would go on top? 2x, perfect. Let's simplify from here and combine our fractions. So we're going to find a common denominator. I can cancel out these 2's. So I have 1 over x plus x over x squared plus 1. I need to multiply by a common denominator. So I can multiply the top and the bottom here by x. And then the top and the bottom of the first one by x squared plus 1. So I get x squared plus 1 plus x squared up top, and then on the bottom we have x times x squared plus 1. And we can combine our like terms here too. What's x squared plus x squared? 2x squared. Bless you. So we took the derivative of both sides, but this isn't our final answer because we just want to get the derivative of y all by itself. We need y prime to equal our answer since we're finding the derivative. So what I could do is multiply both sides by y. Well, what is y? Awesome. Y was equal to x times the square root of x squared plus 1. So instead of just multiplying by y, I mean, that's what we're doing, but we're going to multiply by x times the square root, which I'll call it the 1/2 power. So x squared plus 1 to the 1/2 power. So we just multiply both sides by y. So it'll cancel out here. Now we want to simplify the right side. So I have an x on top and an x on the bottom. That'll cancel. And then I have an x squared plus 1 to the 1/2 power on top, bless you, and an x squared plus 1 to the power of 1 on the bottom. These have the same base, so I can combine them. How can I combine them? Subtract the exponents. Perfect. I can combine them by subtracting the exponents. So the 1/2 is on top, so I'm going to subtract it by the 1 that's on the bottom. We need a common denominator, so I'll make this 2/2. So 1/2 minus 2/2 would equal what? Negative 1/2. Since it's a negative exponent, where is it going to end up? In the bottom. Awesome. So I have 2x squared plus 1 on the top, and then on the bottom, we have x squared plus 1 to the 1/2 power. Or if you wanted to change it back to the square root, you could too. So since it was negative, we knew that it had to go back into the denominator and turn positive. So this would be our derivative. I don't really think that this is less steps or necessarily easier than doing the product rule and the chain rule together, but it is just a new strategy on finding the derivative. So we could do it this way. So we're going to do the same thing for example 7. So with this one, we'd be using the quotient rule and the chain rule for both the numerator and the denominator, which would not be very fun. Be a lot of derivatives in one. So let's see if our ln is going to help us out, make it a little bit easier for us. So we're going to take the ln of both sides. So the ln of y is equal to, bless you, let's expand this. So I have 2 times the ln of x minus 2. Since I'm dividing here, what would go in the middle? Subtraction. So minus 1/2 times the ln of x squared plus 1. So I kind of did a lot of steps in one there, but do we understand how we got this? Perfect. Now let's take the derivative of both sides. What's the derivative of the ln of y? Y prime over 1, perfect. Y prime over y. Now let's take the derivative of the right side. So we have 2 times x minus 2 is going to go on the bottom. What would go up top here? 1. Awesome. The derivative of x minus 2, which would just be 1. Minus, we have 1/2 outside here. X squared plus 1 is going to go on the bottom. What's the derivative? 2x. Perfect. Now let's simplify. So y prime over y equals 2 over x minus 2. We can cancel out the 2's here. We've got a 2 on top and on the bottom. So this would be minus x over x squared plus 1. Now before we multiply the y to the other side, we want to combine these together just to be one fraction. So I need to find a common denominator. I can multiply my second fraction here by x minus 2. And I can multiply my first fraction by x squared plus 1. So I need to distribute here. We get 2x squared plus 2 on top. Be careful with the negative here. I'm going to distribute the negative x into the parentheses. So this would be minus x squared plus 2x over x minus 2 times x squared plus 1. Then let's combine our like terms. 2x squared minus x squared would be x squared plus 2x plus 2 over x minus 2 times x squared plus 1. So this is equal to y prime over y. Any questions here? So now that we got it to be one fraction, what should we do next? We want to multiply both sides by y. Perfect. So I'm going to multiply both sides by y. It's going to cancel out on the left. The y that I'm going to multiply on the right is going to be what y is equal to here. So my whole fraction here. I've got x minus 2 squared up top over the square root of x squared plus 1. I'm going to call it to the 1/2 power. So we multiply both sides by y. Now we want to simplify. In this step, things are usually going to cancel out. So I have an x minus 2 on the bottom. I can cancel out with one of the x minus 2's up top. Anything else? Simplify, combine, cancel. Can I combine the x squared plus 1 and the x squared plus 1 to the 1/2 power? Yeah, they're both on the bottom, so they're technically being multiplied. So what would I do to the exponents? Add them. What is 1 plus 1/2? 3 over 2, perfect. So we have x squared plus 1 to the power of 3 over 2 on the bottom. And then up top, we don't have to distribute up top. Just make sure you've simplified everything you can. So I've got that x minus 2 times x squared plus 2x plus 2. So this would be our derivative. So we're going to look at derivatives involving absolute values. So our derivative of the ln of an absolute value of u is the same thing as if it were not an absolute value. We can just get rid of saying that u is greater than 0 because here we know it's always going to be greater than 0. We're always taking the ln of a positive. In the original ones, it had the little stipulation saying u is greater than 0 because we can't take the ln of a negative. We can't take the ln of 0. So it's the same here. So we put our u in the denominator and the derivative of u would go up top. So find the derivative of the ln, the absolute value of 2x minus 1. What's going to go on the bottom? 2x minus 1. What goes up top? 2. Perfect. So this is our derivative.